Good morning, folks. Thank you for joining us this morning. My name is Sean Burns. I'm with 3C-REN, the Tri-County Regional Energy Network, here working out of the County of Santa Barbara. Really appreciate you joining us. And today we have Jennifer Rennick with Inbalance Green Consulting and Jake Teisinger with Franklin Energy to talk a bit more about reading and understanding ACCA reports. So before we get started and I hand it off to Jennifer and Jake, I'll go through a few housekeeping slides. Perfect. So I'm sure we are all familiar with Zoom at this point, but just a quick refresher, it does help us if you do have your full name or your first name, last initial displayed. You can change that by clicking on your picture and make sure your name is entered there. That helps us take attendance and get you any learning units. We do ask that you mute yourself upon joining the meeting. But I believe there will be some opportunity to participate, ask questions, share comments with Jennifer. So we'll get into that shortly. And we do have the chat function available for you to share your questions and comments during the training as well. Another option available to you is to raise your hand. That can be found under the participant option on your Zoom toolbar. You may have heard I started the recording for this session, so we will post this recording to our 3C-REN's on-demand page, and it will be shared with you after the event in an email as well. Great, and just some quick background about 3C-REN before we get started. So the Tri-County Regional Energy Network, we are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. And our goal is to improve energy efficiency in our region by offering free programs and services for all building professionals and households. 3C-REN is funded by ratepayer dollars, which is collected through a public goods charge on everyone's utility bill. The benefit of this is that there's no cost to those that we serve on the Central Coast. And as a regional energy network, we get to return some of these dollars back to our local economy workforce, which has historically missed out on some of these funds. We do offer 3 programs. We have Energy Code Connect, which serves all building professionals with AIA and ICC accredited courses, quarterly forums on energy code and green building topics. We had one last night. And our Energy Code Coach service with live representatives, experts ready to answer your questions about the energy code. You can reach them online or over the phone. I'll put that link in the chat shortly, and I'll actually talk about it here in a second too. The Building Performance Training Program serves current and prospective building professionals, offering training in technical and soft skills related to the whole building science kind of concepts. And then finally, our home energy savings program incentivizes contractors to educate consumers on energy efficiency upgrades and offers support through rebates. Next. As I mentioned, our Energy Code Coach service now has another way to take your questions, to take anything you want to send in, try to figure out with the energy code. The same number that you can call to talk to someone, you can also now text them a question, an image, something to review. So that's a new way to reach our Energy Code Coach experts, especially handy if you are in the field or you are moving quickly throughout your day and just have your phone with you. So the team will be responding to questions within 2 hours during a normal business day. That's Monday through Friday, 8 to 5 p.m. So we do encourage you to reach out to us. Our Energy Code Coaches are always available to you. Finally, next slide. You do see anyone else? I think I might be the only 3C-REN person on here today, but if you do see anyone else with a background like mine or the 3C-REN logo, please feel free to reach out to us in the chat. You can chat us directly if you do have any other questions or comments or suggestions about upcoming trainings. Send us a message. And finally, with that, I will pass it off to Jennifer Rennick, again with Inbalance Green Consulting, who will lead our training today. So thank you so much, Jennifer, for being here with us this morning. Hand it off to you now.
Okay, thanks. Good morning, everybody. I'm glad you could join us. We're also joined by Jake, who is from Franklin Energy, and he's going to monitor the chat for us. And if you do a raised hand, any of that, he's going to help with that, and he'll jump in as appropriate with your questions. I do encourage the group to participate as much as possible. I recognize a few names on the participation list, so I know some of you have experience. You have plenty of experience reviewing ACCA Calc. Some of you do ACCA Calc, so please jump in with any pertinent stories or information that would help with the discussion. These are the learning objectives. They're here if you're going to get ICC or AIA units. And this basically parallels our agenda. So we're going to start out with right sizing and what that really means and how does that apply to the energy code. We're going to go through the ACCA calculations and talk a little bit about roles and responsibilities. Then we're going to hit on some of the key elements and forms in the ACCA reports and talk about some best practices. And then I'm going to share a few resources for you. And in the end, we should have time for some questions and discussions. When it comes to right sizing the heating, cooling, and air distribution systems in the California Building Code, let me start with saying that this course is starting also at a kind of an entry level. So for some of you, this might be a review, but I want to make sure we're all on the same page with this and talk a little bit about why it's important to right size, or rather design, the duct system, the heating and cooling system for our houses. I mean, maybe it's obvious to a lot of folks, but there is energy conservation in having the right sized equipment for a house. And what that means is that the equipment is not going to be overly sized or underly sized. And when equipment is overly sized, it tends to cycle on, and then it has to turn itself off because it's met its load, cycles back on, turns off, cycles back on, turns off. That cycling process keeps the equipment running in its least efficient part of the mechanical cycle. So having it right-sized means the equipment can be turned on and maintain a low, steady energy use and therefore save energy, but that improves the occupant's comfort. It saves our resources in the state. Having right-sized equipment, there is some natural consumer protection involved in that. And all of that is a benefit to the health and welfare of our community, the occupants, and to the state. For the heating and cooling and ventilation itself, and looking at how we size that equipment and what we're allowed to do for our residential buildings, that has been in recent code cycles interwoven into several parts of the energy code, or rather several parts of Title 24 Building Standards Code. One place that is intertwined is in the Energy Code, which is Part 6 of Title 24. It's also been embedded in Part 4 of the California Mechanical Code and in Part 11, which is the California Green Building Standards Code. And that code gives the engineer or the design installer contractor 3 ways to show that they comply with the right sizing. ACCA, ACCA is the method that we're going to talk about today. You can also use ASHRAE methods. And the third option, it says, or other approved method. But usually we're going to see ACCA and ASHRAE are the two methods that are used. The Part 11 code excerpt for the residential mandatory measures, it explicitly says that under the ACCA calcs, for heat loss and heat gain for the building, you would use something called manual J. That's the residential load calculation. Or you can use ASHRAE, which is part of a lot of other software packages. The duct system itself would use manual D, and the selection of the heating and cooling equipment would be manual S. We're going to go through what each of those manuals are here in a minute. Now, with the mechanical code, Part 4, they do also include balancing as well as the manual D. Now, the manual J, D, and S, as we're going to refer to this, these are publications and methodologies that you can get through ACCA, which is the Air Conditioning Contractors of America. And they follow the American National Standards Institute designation and standards for how this equipment is laid out. One thing I want you to notice, and this may come up if you're new to this, is you'll sometimes see things referred to manual J. Sometimes the forms will say manual J8, which refers to the 8th edition. Sometimes it's shortened to just MG8. And then some of the forms will call for a J1, which is a form designation. They're all referring to manual J, which is how you calculate how much heating and cooling is needed for the residential loads. So let's see. Any questions so far?
No questions yet.
Okay, great. So this part, the ACCA calculations, that's kind of an overall view of these different manuals, what they're called, a little bit of the terminology. And now the ACCA calculations, we know they're part of the building code. We know they're part of the energy code, mechanical code, green code. But there seems to be kind of I don't know if confusion is the right word, but there's a little bit of back and forth. And how do we use ACCA standards, which, by the way, is a tool. It's a tool for the installing, designing contractor. ACCA comes out of that industry for those folks to right size and design their duct equipment, choose all the components, choose the right ducts, choose everything they need to have a complete system to install a house and operate beautifully. And when the ACCA calcs came into the energy code, not every not every HVAC contractor actually was performing ACCA calculations or any kind of right sizing at all. A lot of times they used some rules of thumb and a few charts here and there, but they weren't very methodologically following through on this. So what we ended up having is authorities having jurisdiction, the enforcements were asking for these ACCA calcs, going back to the architect and saying, okay, I need these calculations for the systems. The architect's like, wait, what? We don't even have a mechanical engineer on board. This is residential design. So we don't even have a general contractor on board. What do we do? Well, some HVAC contractors offered ACCA calcs. Some HERS raters started offering ACCA calcs. Some energy consultants who do the Title 24 started offering ACCA calcs to the architects. So those reports ended up being fairly generic and weren't necessarily being done by the installing HVAC contractor. So this is where we are today, where if you're lucky, you'll get a report that's done properly. But a lot of times you, as the authority having jurisdiction, are going to get a fairly generic report. So I want to kind of go through some of the red flags that you're going to look for or could help you in the plan check process and help speed up the process. And also give you more confidence on if you see something that doesn't seem right, to send it back, or to say, yeah, that's great, you have this generic report, but now we need the report by the actual installing contractor to make it real. The ACCA residential HVAC design process in general, this is what ACCA lays out, is you would do that load calculation, which is the manual J. Then you're going to choose the actual heating, cooling equipment and everything else with the manual S, go into the duct design, lay out the duct, design the ducts, which is manual D. That sometimes is an iterative process where you may have to go back and choose new equipment selection, or if the process is very thorough, you might even be able to go back and talk to the design team to improve the design of the building. Then you would go into the air distribution system, manual T, and test balances adjustments, manual B. So we're going to focus most on the manual J, S, and D, which is called out in the energy standards and the green building code. It was the mechanical code that specifically calls out the use of manual B. And visit the ACCA.org website for references and more materials. Now, there's a parallel kind of a process here with the Title 24 Part 6 Energy Code documentation. So I just threw this up here to give you, to just remind people, and if you're new to it, you're gonna, Sean, we're gonna give copies of the slides to people after this. Is that correct?
Yes, correct.
So this is more a little bit for reference, just to highlight which parts of the Title 24 documentation has a parallel or cross-reference with what you would see in the ACCA calcs. And on the compliance side, the initial submission is going to be a performance calculation on a new residence. If they're not doing a performance calculation, then you're really depending on the ACCA calculation and comparing to what might have been done prescriptively. And then you've got your installing and your after install, post installation forms, CF2Rs and CF3Rs, that go through a lot of it with the duct design. Duct location is really important. And with that, this is kind of thick, so I'm going to keep going. Okay.
Hey, Jennifer,
Yeah.
before you go on, a couple of questions that came in. Do you know of any publicly available samples of completed manuals?
Completed, oh, like a completed ACCA report, ACCA calculation.
I think,
And yeah, there's, yes, actually, I mean, if you go to the ACCA website, there are a number of courses you could take, the webinars where folks are trying to walk you stepwise through how to do those ACCA calculations. And if you do that in a way, you're going to get a report that's completed. There's also, another website. I think it's unmet load hours. I think that's the website itself, unmet load hours, where they have laid out some reports that are completed with little captions underneath it. And then this resource here is going to at least give you excerpts of completed reports and key things to look for. And then I'll show you at the end, ACCA has 3 brochures that they're packed with information. So I think when you're first getting into it, these ACCA brochures are really information packed. So I tried to pull out from that the most sort of important things that we might see in our area that could help you.
And Jennifer, those are free and they include methodology guidance, right?
Well, they're free. Yes, the courses include methodology, yes. And then to really get into it, you do need to buy the manuals and software if you're going to do the ACCA calculations yourself.
Great, thank you.
Well, here's a list of the items that you could expect to see in an ACCA report. There are, if you, for example, engage with RightSoft software, which is one of the official softwares that are the, manual J powered, quote unquote. And it's the most common software I see people using in our area. You can have these forms printed out plus a lot of other ones. So remember that the RightSoft software and the ACCA methodology was really to help the designer and the installing contractor do their work. But then we took parts and pieces of it and the code said, okay, we want to see that you've actually done your work. So as a plans examiner, you may only get a portion of this, but these are the forms that at a minimum, I think that you would want to see and ask for. So under the general information, there's a form called a plans examiner review form. We'll take a look at that. There's also something called a project summary form. I personally like the project summary form, but and that's because I like to use it as a tool to see where my where the energy is going and to give it one concise little sheet. The manual J is for looking at the loads on that building. So there's the J1 forms I mentioned and worksheets, and there's a load short form. There's a building analysis. Again, my favorite on this too is the building analysis because I use it to spot check. Takes the same information and puts it into a pie chart. And so to me, it's very interesting to look at that pie chart and to see, for example, are any windows listed on the pie chart as contributing to the heating or cooling loads? No windows listed, I'd send the report back and say, okay, you got to do this again and put the windows in there, for example. And I have seen that with no windows at all in the reports. Manual S, that's pretty straightforward with the one form. And then the duct design, you'd need your sketch to show it. Friction rate worksheet, duct design summary. Now, what's not in the software, but you also would want to ask for is the equipment specification sheets. That's called OEM in the forms. That's the original equipment manufacturer's performance data. And at a minimum, the make and the model, the efficiency, the capacity, but also you have to have the blower data or the external static pressure and fan performance data in order to even know if they did these other forms correctly. And I noticed a lot of times these forms are never included with the ACCA calc. So it's almost impossible for you as authority having jurisdiction plans examiner to know if these ACCA calcs are valid or not. And then that's a whole nother discussion we could get into, like what's the job of the plans examiner? Is it to see that it's valid or just to see that they did it? This form for the residential plans examiner review form, the idea with this is RightSoft put it in here that the person could print it out for you. And the idea is that they would actually tell you if these required attachments are actually attached or not. Most of the time I see this form submitted, but these check boxes are not checked. So you could also, as a plans examiner, use it for your own benefit and say, oh, they're missing a chart and or missing a form. And typically the two that are missing is that OEM, the blower performance data, and something called a friction rate worksheet, which we'll get into in a minute. But this top part of the form gives you these. The top two, the manual J1 or MJ1AE, we're going to only talk about the manual J1 form. I haven't had any projects that use the second option, and that is more or less a checklist as an alternative way to show compliance. But for what we're doing, it's just the manual J1 form. So I would expect to see, yes, that's attached, the OEM attached, manual D rate friction attached, and the duct sketch attached. We're going to highlight a little bit about what really goes into the manual J load calculation, but each one of these things, I mean, would be hours and hours of coursework to learn how to do it. But from your perspective, how do you get some kind of congruency between these requirements and, say, the Title 24 energy calculations and all those forms and what's required? So give you kind of a big picture overview. You do use approved software, and in your Title 24 world for performance calculations, you're also using an approved software. They both will do load calculations, and they both take into account very specific climate data, the building's orientation, all the wall assemblies, all the windows, all the doors, your roof, floor assemblies, infiltration, ventilation, IQ, and occupant load. And that's a lot, I think, for a plans examiner to thoroughly check all these things, but there's a few things you can look at just to make sure they're actually and there. And this little chart I'm giving you guys is to give you an idea of what things to spot check that would have the most impact on the energy use and the compliance. So you may not have time, for example, to note if every single solid door is in the Title 24 and in the ACCA calcs, but in my opinion, if I see a few doors there, I'd be like, okay, they got some doors in there, good. And I'd move on because the doors are going to have the least amount of impact. But if they had completely wrong climate zone, okay, that's a big deal. Next, in our Tri-County region, duct location is huge to note that. That will make a big difference in all your compliance work. Also, orientation, but especially the window orientation is important to note. So again, I kind of look at it big picture on that. And then I go into the windows, walls, roof, floor assemblies, etc. And on here in this area, I wanted to lay out some useful kind of information for you and just kind of highlight the things you would look for. So on the building orientation, for example, if you notice a huge part of that house is facing south and west, then that's going to be really important to note if they really got the bulk of all that windows and glass truly facing south and west. East and north are a little less important in our climate zones. And then I've given you some kind of rules of thumb for you factors just to take note of in case you don't have those memorized like I do and some other people on the call. For those of you who don't, this is a quick little check just to see, okay, is it close? Does that make sense? Now, ACCA, this is an excerpt from one of the brochures. They have a slightly different list, but ACCA is, it's really broad. And I've created a list for you that's more specific to our climate zones for our Tri-County region. Now, the actual form that you're going to get, Form J1, and the worksheets going to look a bit like this, which on the right. And to me, that can be really daunting, especially if you're just starting out at looking at this. So what I tried to show and kind of make this big, highlight it on the left-hand side and put the arrows onto the important things to look at is certain red flags. So in general, this TY here type, it's the building tree. W's for walls, G's for glazing. So it's like they call it a parent-child relationship. So under this wall, you would have several windows. Under the next wall, several windows. Okay, that's good. Sometimes I said I've gotten these reports where I just see floor, wall, door, roof. Done. No windows. Okay, I would just send that back right away. So this looks good. I see that there are windows. Next, I would come over to this column that talks about the gross area of those assemblies and see if that makes sense for the windows. Okay, you've got a large window with 84 square feet. Okay, that's maybe, sliding glass door, 8 square feet. Okay, that makes sense. That's that small window that's on the house. Like, I would spot check these to see that it makes sense. Next, I would go to the U values or the U factors. Oh, by the way, U value, U factor, same word, interchangeable. Professionally, people use both words all the time. Perhaps U factor's technically more correct, but you'll see it U value or U factor both. So I would take a look at that. And these should match the Title 24 report. So if they're doing a performance report or even the prescriptive report, those things should be congruent. If you see on your ACCA calc, it's very, very different from what's in the Title 24, that might be a reason to send it back. It means their load calculations won't be accurate. And then another quick spot check is just to see if the floor and ceiling areas align, especially if it's a single story house, for example, you have the same area floor as you have for the same area of ceiling or roof. If they're the same, okay, that's a good sign. If that floor area matches the plans, that's a good sign. And that's how I spot check those. And I've given you some U factors down here. This one, 2x6 R19. In a lot of our climate zones, we're seeing that the projects are trying to mitigate away from using exterior insulation. So I always keep that 2x6 R19 with the U factor of that value kind of in mind so that I know if they're roughly congruent with what reality is. Let's see. Any questions on that coming up?
No new questions in the chat.
Okay, so then on the MJ8, so Manual J, 8th edition, Form J1, one of the other things I quickly look for is under duct locations. And this is the heating load factor and sensible gain factor of the duct system itself, which means that the duct work is going to lose heat and gain heat. And if that duct is in an unconditioned attic situation, you're going to expect there's going to be a certain amount of heat transfer through that system. And when I see a report with all zeros in these areas, I know there's no heating loss, heating gain through the ductwork. So that's the thing to spot check. If you see all zeros, just that means that the ductwork is entirely within the conditioned envelope. And so that would be something that could be pretty easily verified or checked. And if the ducts, you know, are in an attic space, a conditioned attic space, and you see all zeros there, it's like, no, this report doesn't match the conditions. You could send it back. Any questions on this part of the form? That's my biggest favorite kind of red flag to see on this one.
Nothing new has been submitted yet.
Okay, great, thanks. Okay, the load short form. This is gives you some helpful information, and again, these are kind of the things I look for in spot checking, and I want to know right off, does the climate look appropriate? Is it coming from the California Joint Appendices? And I have had reports where the climate was completely different than the Title 24 and the location of the actual building. And we have sent it back only to then have the person who created the report now change something else, because once they got called out on the climate zone, they had to change other stuff to get this equipment to pass. And that's that's the kind of stuff that plans examiners have to deal with. Unfortunately, there are some people in our Tri-County region who choose the equipment first and then try and make a report that matches the equipment they want to sell to the contractor or to the homeowner. So these are some things that I would spot check and not be afraid to send back if the climate doesn't match. And also, one thing I take a look at is the rooms and floor area and kind of the relative load. And it gives me an idea of the impact at, a glance. But again, I've been looking at these for a little while. So on these, I would expect to see, this one might be a little bit harder, but you can get an idea of the area, the floor area for these, and see if things make relative sense. And by that, what I mean is I have seen reports where the floor area has been purposefully or accidentally reduced, but the surface area of walls have inadvertently been increased, or vice versa, because it shifts the loads. And so this is one thing where I just spot check it and say, okay, does this make sense? Do the east facing walls match the west facing walls? North and south walls, do they match each other roughly? Floor ceilings, do they match proportionately? Does it make sense that you would have that kind of wall area for the floor area, etc.? When it comes to the Manual S equipment selection, this is the part where I think it's the most difficult for a plans examiner to know if the equipment selection is really based on reality, if you don't get the cut sheets for the equipment. That coincides with the Manual J and with your Manual D calculations and drawings. So you're going to want to see the heating capacity output, cooling capacity output, and the blower performance data. And this will take you through that process of choosing the equipment. There's the Manual S compliance report, and it's broken into your cooling equipment side of it and the heating equipment side of it. And there's just a couple of things I spot check for, and this year might be a place for some discussion, because I know that some of you have seen um, different things on the manual S compliance report in terms of, is this piece of equipment within a particular range, size range, that's supposed to be part of the whole right sizing requirement under the code. So under the cooling equipment, first I do a quick look at the location, the climate, and was the indoor design temperature 75 degrees for summer. Okay, usually you're good on that. And then what I take a look at is, does the capacity of the equipment meet the load of the equipment? So we did the manual J load. Now we're looking at the equipment. Are those things reasonably connected or reasonably sized with each other? And it's okay to, you want to be within this range, 100 to 115%. That's how you know if it's right sized. If it's not, if it's too big, is there a smaller unit available for this house in this line? Sometimes there isn't, and that's valid. But if there is, then that's what we want to look at. Sometimes the smaller size is too small, so that doesn't meet the loads. The other thing I want you to take a look at, and this, I do get questions on this, is for our climate zones. Our climate zones are known in California to be dry. We have a dry climate. So in other words, with a dry climate, you're going to have, mostly you're going to look at your sensible loads or sensible capacity and compare them. And sensible is the heating, is that, sorry, is the cooling you're going to feel excluding the extra moisture in the air. Latent capacity has everything to do with the moisture in the air and the ability to take energy out of the system by condensing the moisture, pulling the moisture out of the air. So you'll notice on this particular piece of equipment that our sensible capacity is within 106% of the load. And I think I'm not sure if you can see my arrow, but it is up here at this top part there, or where the arrow is. And if you take a look at the latent capacity, it's over 600% of the load. So clearly you're not going to be within that range, but that's completely normal for our climate zone. We're going to have the equipment itself is going to have the ability to take a lot of moisture out of the air, but we don't need it. So that part's fine. So then when you take the two together, now we end up with a total capacity that's at 126%, which is more than the 115%, but that's okay. In this case, that's normal because we're in a dry climate zone. So I to say, if your sensible capacity is within that 100 to 115% range, as a plans examiner, I would call that good. Now, for the heating equipment, same sort of thing. We're going to look at the climate. We're in 68 degree Fahrenheit for winter for our design temperatures. Yeah, that's usually true. Then we take a look again at the capacity, and does the capacity meet the load, and is it within 100 to 140%? If not, is there smaller size available? But sometimes the equipment is sized for the blower, and you are going to end up with a piece of equipment that is greater than 140%. And if you're not sure, you can send it back to the folks who produced it, and they can give you comment back and tell you the reason why it's greater. Sometimes it's because the equipment, it goes together with the cooling, and when you have the blower, when you have the fan you need to meet your cooling loads, you're naturally going to be oversized on the heating. And I see that like with our hotter climates, like climate zone 4 And you can see that with climate zone 9 at times. And so in this particular example, the cooling load is 183, the heating is 183% of the capacity. And that's normal because these two equipments go together. When in doubt, ask. But I'm sure some of you'll have examples of this where the situation might call for not falling exactly within what the ACCA guidelines say on these capacities. Feel free to chime in on the chat or jump in or questions at the end. On the manual D duct design, this is the one I see that is most common for the plans examiner to look at and kind of know or feel more comfortable making comments about. And that is great. I'm going to go over a few things to to look for on this. And if any of this isn't congruent with the other forms that you would have received, then again, feel free to send that stuff back. But this is really, it's interesting. So, I can see a lot of plans examiners are very more comfortable with this part of it. At the same time, there isn't too much they can do if they don't actually have the equipment specifications from the installing contractor. So when it's really generic and you don't have that information, it's just like, okay, they've got a duct design. Great, you did it, check, and move on. But in reality, this takes into account all the duct sizes, the diameter, the duct lengths, the connectors, the reducers, the other fittings, the elbows, and really determines if the blower, if that air handler side of things is right sized for the duct system. This is what you'll often see turned in on the right. The equipment maybe is called out and you'll have a floor plan and you'll see that they've put in windows and walls and it's a rough sketch and doors and they've got the room shown. And so all that looks great. And they have put in where their branches and trunks are and register locations. And the software will automatically call out the sizes, the diameter, or if it's square duct, they'll call that out. The software automatically calculates the supply air volume rate and the return air volume rate, and it's all labeled and it's shown on the plans. Okay, looks pretty reasonable. Sometimes what I'll see is some of the ACCA calculation and the folks who are installing it, when they make it as real as possible, you'll notice they'll put sometimes curves in the ductwork instead of a straight line just back to the equipment. They're trying to lay out the actual length of the ducts the way the installing contractor might do it, because that length of duct will impact the friction rate, which impacts the blower. We're going to talk about that right here. So part of the duct system summary sheet is giving you, as a plans examiner, you can look at this and say, well, okay, under the supply branch detail, supply trunk detail table, return branch detail, you can see they've laid out a lot of equipment and done a calculation per room, what the peak loads are. Okay, fine. I think as a plans examiner, this is maybe not useful information to spend too much time on, but what is this top part here with the heating and cooling in terms of external static pressure. And that external static pressure actually comes from the manufacturer's blower performance data. So when you choose that piece of equipment, that's where you get that external static pressure. What I've noticed for a lot of generic ACCA reports that are turned in, the architect has to turn them in. They don't have anyone designing the system. They don't really have anyone choosing the equipment that accurately. And I'll see a lot of times just generically, they'll choose a 0.5 static pressure and they will roughly lay out the rest of the this equipment. And how do I explain this? For a plans examiner, what you're going to end up looking at and what you want is for them to give you this blower performance data. You want them to tell you, like with an arrow or some red box, indicate which piece of equipment they've chosen. So this is the equipment that they had chosen. But even within that, even as a plans examiner, if you take the trouble to go find this cut sheet yourself, it's not always clear if they've got the right blower in there and the right static pressure. But if you have them call this out for you, it makes it a lot easier. Now, this sheet here just shows you where some of this information is for pressure losses. That's determined by the product data information. I'm going to show you on the next slide. There's something called a total effective length, which the software calculates for you, which is just part of that whole manual decalculation. I'm going to show you on the next slide. And this, it just gives you the summary, and it says what this actual airflow is here. And it's 1,068. And this is the blower that they chose. And when it's set on medium, this is really close to this equipment. So all this seems consistent. Now on this is the red, this is the one form that I think as a plans examiner, you can jump to pretty quickly and see if this friction pressure or static pressure and friction rate worksheet was done. This is the one that I want turned in because I'm going to jump to the bottom. What you as a plans examiner are going to look for is right here, friction rate. Do you see the words okay? Do you see 4 okays? That's the question to ask yourself. If you see the words okay, that's a good start. I'm going to explain what's on the sheet, but that means that they have paid attention to the actual duct design and it's working. Now, sometimes I will see forms, they'll go through the whole thing, they'll do their duct design, they print out the forms, but you won't see an okay here. You might see something like less than 0.06. That's not okay. You really technically should be sending that back. The duct design means that they have an inadequate fan performance. They might need to change the blower. And that's what this red zone indicates on this chart. And I added this chart here because these bullet points, highlights kind of tell you what that means. Sometimes you'll end up seeing where the fan is too powerful. And it's in this bluish purple area. Again, these numbers here under friction rate are not going to say okay. They're going to say it's greater than blah, blah, blah. And those are reasons to send this back. Now, how this is determined is by doing the available static pressure part of the worksheet. And roughly speaking, as a plans examiner, what I spot check is, for example, does the equipment include a coil and are there pressure losses? In this case, this equipment did not, so it's 0, which matched with the cut sheets we have. There's no additional coil in the air handler for this case. The supply diffusers, return grills, if you don't know what they are and you're doing a generic report, it's really common to see these all as 0.03. If I saw 0.03 for these, it wouldn't raise a red flag. And for the filter itself, it's going to, oh, okay. And if Judy Rachel, I just saw Judy Rachel's name fly up. If she has something to say, she can unmute herself and just chime in, because she knows. She knows this stuff.
So Jennifer,
So,
if you can hear me, I'll just speak quickly.
yeah. Yes, do it.
Yeah. So just in what you were saying about immediately kind of looking to change the equipment because the blower motor can't handle the restrictions, I would first say to look at your evaporator coil and look to change that and get a less restrictive evaporator coil. Then I would be looking at the duct system itself and be looking to possibly change some of the fittings or sizing of the ducts, and also looking at my grills. And unfortunately, most of the numbers that people put in to get to their total friction rate and static pressure are generic numbers that have just been tossed out there, and they're not actually looking at their various pieces of equipment, at their evaporator coil, to see what its actual restrictions are, what the grills that they're chosen, what their actual restrictions are. So I would look at the distribution end before I would turn around and choose a different piece of equipment.
Yeah, yes, that is so true. And from the plans examiner's perspective, really, I think the only thing you can do in this case is to just make sure it says okay. That's what you look for. And to make sure that there isn't anything really wildly crazy. When I say crazy, how would you know if you don't actually do this work? Like the 0.03 for those grills. Okay, that's generic. Sometimes what I've seen is on the filters themselves. Oh, and Judy could probably speak to this for sure. On those filters, we're supposed to have a MERV 13 filter, and unless you know, and oh God, it's so hard as a plans examiner, how would you know? But the filters, that can vary wildly. So if you have a small sized filter, but it's MERV 13, you would expect a pretty high static pressure number in there. So I've seen some that are quite high, and then other times the filter that's oversized. I mean, they make it large size so that increases the surface area so that static pressures drop. Sometimes that requires making a specialized box for it. But you, as a plans examiner, you wouldn't know that either unless you ask them to also give you the filter specifications on it. So it really, I think it's going to depend in the plans examiner 30 having jurisdiction, like what the skill set is, the expertise of the folks that are reviewing the ACCA calcs. But I would say, hey, look for the okay. Tell them to give you the filter information, and also ask for those cut sheets. At least you're starting to get close to reality if you ask for those. Okay. Anything you want to add, Judy? I love, and anyone else actually too, on what you've seen, because this is, I think this isn't easy for plans examiners to have to look at these things and to really know what to look for when I think of all the other things you have to look for in a building. And then this is so engineering brained. It really is. It's like, where do you even start? So hopefully those things that I've laid out would be some of the major red flags you could at least look for to see if there's some a semblance of reality in these calculations, and maybe kind of cover yourself in that department in case something did come back around. You weren't approving something that didn't have the windows or completely had wildly wrong climate zones, or the friction rate loss report itself didn't even say okay. Those would be some of the things I think you might want to add to your kind of checklist. When it comes to the best practices, I would think each of the departments, and I would love for some discussion on this after we get through the last couple slides, is, what do you look for, and maybe create the ACCA checklist of the desired forms that the department wants, that they're going to put out there to the customers, so to speak, so that they know ahead of time. Expect to include your static pressure friction loss worksheet, for example, that we just talked about. Expect to include the manufacturer's performance data. I'd actually add the filter data in there too now. And if you have the time, the bandwidth, the ability as a plans examiner, if you know that that's going to be your job to look at these ACCA calcs, I would get the software. I contact RightSoft or contact one of the available software providers and ask them, tell them that you're working for one of the authority having jurisdiction planning building departments, and ask if you can have a copy of the software so that you can play around with it with the right J and the right D software yourself and really see, okay, this is all they have to input, or okay, this is a limitation on what they can input. And then you would feel more comfortable knowing when you see things that aren't quite right to send it back and get something that is real, or no, at least there was some, level of care taken in producing this. Here are some of the resources that are available. If you go to ACCA.org, they do have these 3 brochures for the Manual J, Manual S, Manual D, and I'm going to show you screenshots of what's inside of them. They're full of information. I think if you're new to this, the information and the amount of things to check for as a plans examiner, in my opinion, is overwhelming, but as you do this more and more, you would probably just be able to add to all the things you could quickly spot check. But the reality is you're only going to have a very finite amount of time to look at this and not always be able to go through it as detailed as what's laid out in the charts. The other resource that I think is very helpful, even though, okay, published 2013, that part isn't so much, it's not that it's old, it's that the HVAC guidelines of why to right size the equipment is still valid. So I think it's good to read this because this really spells out why the right sizing requirements have become part of the code, and this, just having that vocabulary and background might also help you with your own sort of dialogue or narrative of how you're going to speak to the customers and the homeowners if you're interacting with them. So this gives you page 2 on the Manual D brochure, it does give you an example of what a friction rate, worksheet, what that calculation would look like. It kind of runs you through the example of putting it into that friction rate chart. It highlights key components. And so this is a one-page kind of everything approach, which I think is helpful to have on hand so you can kind of match a few of these things with the slide deck you're going to get from us, and when you look at those reports that you get from your customers. This is the backside of the right sizing for, equipment selection for Manual S. And this, again, highlights these points. I would read it through and have it handy, knowing that you will most likely not be able to go through this on every project, but you're going to want to see that your equipment was selected. Is it generally within that 100 to 118% range for the cooling and 100 to 140% range on the heating? But again, knowing that sometimes those things are going to be out of range if you can't get smaller equipment, which sometimes happens with our climate zones, and knowing that we're in a dry climate zone, so we're going to look at the sensible and latent loads a little differently than just the total load. The other thing, mini splits now. We're seeing more and more mini splits with concealed ductless, they're sometimes called, or concealed duct designs. And so those allow for much more compact and equipment layouts, and those do go to those smaller sizes. So it's possible that if it's something is like 200 times oversized, you can send that back and say, hey, this needs to be, you need to go with a different equipment line possibly, or any of the other things that Judy could recommend. Backside of the Manual J, it's checklist. It follows really similarly to, it's more detailed than the one that I put in the slide deck. This is sort of like everything, but I would just pull from it the ones that impact our climate zones the most, which was on the slide, which was on the previous slides, and you'll have a copy of that. Okay, with that, I am going to hand it over to Sean so he can talk about some of the upcoming courses, and then we will come back for questions, discussion. I know a lot of folks on the call have some experiences with some of these things, and I would love to hear about it, really, because I think some of this is discussion for how all of us can maybe share some of the things we've learned to best help all our code officials work through these requirements for the ACCA and the right sizing. It's not going away. It's still part of the new code coming up in January. So really, 3C REN, we wanted to put something out there to help start facilitating discussions and maybe helping folks have a better way of addressing this and help the state move towards a goal of overall energy efficiency and a cleaner energy grid. Okay, Sean.
Absolutely. Thank you, Jennifer. And yeah, we'll have some time for questions in a second here. If anything comes up in the meantime, use the chat, but again, we'll have a little discussion afterwards. While I run through this slide, I will also launch a little feedback poll. I would appreciate if you take that. It's 4 questions, and I'll run through my slides while y'all are doing that as well. All right, so for today's course, again, thank you, Jennifer. Really appreciate your expertise, and Jake, appreciate you helping out and providing some support with the chat today. So just want to thank you. For our attendees, we do have learning units available for this course, AIA and ICC. If you were able to enter your AIA or ICC number during registration, we have that information. We'll put those in the portals, and you should see those available in your account in about a week or so. If you weren't sure if you were able to enter your learning unit or your number, please reach out to me. My email is on the screen. It will be in the slides that we send out to you as well. Or if you need a attendance certificate for another program that you may want to submit this course for, we can provide that as well. Like I mentioned, we'll have an email coming to your inbox this afternoon or tomorrow morning with the slides from today, so you can review all that helpful information. They're recording if there's a spot you want to go back and re-listen to. And we do have another survey there where you can suggest or provide additional feedback about this course and suggest other training topics that you may be interested in hearing about. As well, we do have a few upcoming courses. We have the value of becoming a certified energy analyst. So if you are at all interested in energy modeling, this may be helpful for you, or if there's someone in your network that you'd like to share this training with, learn more about energy modeling, that'd be a great one. That's actually next Tuesday. And then we have a household event talking about ADUs. So that may be more for the general public. Feel free to share that with anyone in your network. And again, we'll bring back our all electric construction series. This is part 1 of 2, and we'll discuss heat pumps for heating and cooling. And we do have our full spring events calendar now available. So shortly after I stop talking, I'll put a link in the chat to the flyer we've created listing out our full events through June coming up here. So thank you all for taking the feedback poll. I'll end that now. Looks like we've got some responses. And I think we can move to the next slide, our last slide, and open it up for some discussion here as well. Any final questions?
Nothing has come in through the chat yet. But I think we're open to either the chat or if you unmute yourself and want to ask over the phone.
Oh yeah, unmute yourself. I can stop share and we can go to the talking heads, the screens. Yeah, so I recognize some of the names. I'm sure there's some I don't know, any examples, any stories anyone wants to share some of their experiences, or if you have ideas of things that seem important or easy to look for when you're doing the plans examination side of it. I would love to hear other people's input on that. What say you, Judy? What would you look for if you were wearing the other hat and doing a plans examination? Am I putting you on the spot?
Yeah, so I go through other people's load calculations incredibly thoroughly, which is way more than what a plans examiner would ever do. So yeah, and I haven't had to do it in a little while. So off the top of my head, I can't think of anything. I guess what I would want to add and maybe start a discussion on is just the fact that the software, where it is incredibly helpful, is also limited. And the designer has to make a number of choices when they're building the buildings in software that might not look like they are reflective of the building, but it's a choice that the designer had to make to figure out where to put some of the load. And just there's just these limitations that the software blocks us with. Especially like rooms above or rooms open to above or open to below, spaces like that, where, you know, we need to manipulate the software so that we can actually even show the duct design appropriately when because of software limitations. And then a second piece is that within the software, there's all these different fields. And Wrightsoft has, you know, put numbers from 0 to, you know, to actual numbers in the various fields, and pretty much none of those are defaults. The designer has to know that they need to change those fields, and they also have to know what fields actually apply to they're building a load calculation versus they're looking for an energy analysis. And that can be confusing when a plans examiner or somebody else is looking at the reports, not knowing whether the designer actually changed those fields to be reflective of what's actually going on in that building, or if they just left the defaults. And that goes for like the duct design, as well as the grill sizes and things like that, is that we should not be allowing the software to make those choices for us. The software can help us make those choices, but we need to look at those choices and make changes to them when appropriate. And mostly it is appropriate to make changes off of what the software has decided for airflow, for duct sizes, for grill sizes. There's a lot that's going on, and a lot of that depends on that OEM information that we should be looking at in making those choices. So kind of without that information to look at, as a plans examiner, you don't know that somebody's using, a good grill versus a restrictive grill, and why the size might be different than what you've seen on other plans. So you kind of can't just generically go, oh, that looks like the right size grill for, that duct and that load.
Judy, you've hit really, that just hits on the whole limitation of using a design tool for the industry as a way to show there's compliance with the building standards, and so I think you make a good point. Without the actual cut sheets, without the actual materials that the installer is going to use as a plans examiner, you don't really know if that report is accurate. And especially, someone like Judy, if you don't know, Judy will design you a real deal system and get everything spec'd out, and it would be installed like that. And then there's those of us, I'm in this camp, I'm an energy consultant who will do ACCA calcs for the architects who needs it. And first thing we do is we say, well, who's going to install it? Who's the installing contractor? If they don't know, we call one of the installing contractors. We say, well, we can't do it until we get a real design, and then we match it up with what they want to install. So it's a bit of a disconnect when you do get a report from someone who's going to have nothing to do with the design. So I would think that as a plans examiner, you could look for these key things and not be afraid to send it back, but also to ask that the report be updated. So they give you a report to get their building permit going. And now that they've got the builder and the real installing contractor, ask for the updated reports to match the design. That's what I would do. Anybody else want to unmute and add to that? Or if you have a different perspective, we're open. I would love to hear. I really want to know what you all are seeing or doing, or, you know, I recognize a couple of names. Feel free. Feel free to chime in. How are we doing on time, Sean? Oh, we're doing good.
Yeah, we're almost there. We're still have a little time left, but we're almost there. And if there are any other questions that come up, I will mention the Energy Code Coach service again, another resource available to you. You can submit your questions online or by email, as text, or through text or a phone call as well. So Jennifer, if the audience is a little quiet today, maybe if something comes up in their practical applications, or if they are looking for an example form, that Code Coach resources is also available to everyone to find out more information or ask a question.
Yeah, that's right. And I think um, uh, the feedback I got from the planning and building department here where I live is getting a hold of the software itself, even though they're not obviously going to produce the ACCA reports, but they just got it for the office so they could. I know I mentioned it in this slide presentation, but I think also because of all the things that Judy said, it's a really good reason just to get it, look at it, play around with it, watch some of those live or the courses that have been recorded on ACCA, and you would begin to see kind of where those limitations are and what you can ask for and what seems appropriate. I don't know if in a lot of your regions, but in our area, we do have a couple of organizations that basically choose the equipment first and then try to do the reports to match the equipment after the fact. And that's where I think you could be empowered to send those reports back if you see any of those major red flags, like completely wrong windows, completely inappropriate walls, no windows, no duct losses and gains, even though the ducts are going to be under the floor or in the attic, those types of things. Well, I want to say thank you to everybody and thanks for attending. Thank you, Judy, for jumping in. I always enjoy that. And we'll give it a couple more moments for any questions or comments. And then with that, I think we'll wind it down.
Yeah, Jennifer, I think that sounds good. And thank you so much, Jennifer, for your expertise, and Jake, your expertise as well. And everyone for joining. Really do appreciate you taking some time this morning. And I think that's it. So I'll go ahead and end the meeting, and I'll talk to y'all later.
Okay, thank you, everyone.
So,
Bye.
bye.
Bye.